So now we had this sum being calculated in main. Now we want to do it in the function. So let's see. I will change directory, reach the correct place. If there are questions in the middle, anytime you interrupt me. So let me copy sum2 to sum3, and in sum3 I am doing the first part of the statement. Okay, so that's fine. So now calculate sum. How many arguments is it taking? 2 arguments. And what is it returning? It is returning one value. Okay, so let's start writing calculate sum. It's a function. So how do we write functions? We declare a function like this. We say return type, function name, and then arguments, and then it has a body. That's the nature of all functions, right? So right now, what is my function name? It is calculate sum. Calculate sum. What is it returning? It's returning a int. What is it taking? It is taking 2 arguments. One of them is ARR, second of is num, how many integers it is. What is the data type of num? It is int. Yeah, the second argument is int. What is the data type of the first argument? It is int array. So you can write it like that. Okay, and then you can write some code. We will see what is that some code. We will write that, but the first victory is to get the prototype right. If you have got the prototype right, that these are the arguments, there are 2 arguments, ARR and num. Num is int, ARR is array of integers, and it returns int. If you have done this much, then you are halfway done. We will see that there are 2 other ways of writing the prototype which are equally good. You can write it like int star ARR, because array of integer and pointer to integer, they are very similar. Pointers and arrays are similar but not same. So pointer to int and array of int, they are very similar. And actually, when we are talking of function arguments, these 2 notations are identical, because even if you if you have the prototype, like I'll write 3 prototypes and I will claim that all 3 are equivalent. If you write like this, if you write like this, if you write like this, it makes 0 difference. Literally they are same. What it means is that if I, in the calculate sum, if I print size of ARR percent LD, okay, and size of ARR, in my machine it will be 8 bytes. It's worth a pointer, and this size of ARR will be 8 bytes whether you give the prototype like this as a explicit pointer, or you give the prototype like this as a array of unspecified dimension, or you give the prototype like this as a array of specified dimension. In fact, when you specify the dimension, the compiler will ignore the dimension, because the fact is, when you pass arrays, whether single array or double array, they are always passed as a pointer. Only the base address is passed. So any of the prototypes will work. I will, for sake of intuitive elegance, I will choose the line number 14, because line number 14 is syntactically representing the reality. It is an array and I am saying it is an array. Line number 13, one never knows, is it one integer or sequence of integers one after the other. So from elegance perspective, I will say this is good. This is not representing reality literally, and this is kind of misleading. Who knows, 100, the dimension may be different. So anyway, I will choose that prototype initially and I will comment this. You can experiment and convince yourself that when you pass an array, it is a base address pointer which is passed. You have already seen that when I print size of ARR here, it is the size of the array. That means size of int into number of elements. Never mind. So now I have passed it. Now I can happily reuse my already tested logic which I had kept. So I will say to dd, I will copy some lines, I will put it here, and I will modify some stuff. After all, it's the same logic, only the data is coming from here and there. In fact, I am lucky that ARRI works as it is. Okay, so this should work as it is, and I need to have a I, and I need to have a sum, and sum I need to initialize to 0. Great. And I have computed it well. Of course, the length len I don't have, I have num here. Okay, I will change that. Or why can't I rename it to len? Len is much more intuitive. So I have done the sum. The only thing remains is return sum. So that's it. My function is ready. It takes array and number, it computes it, it returns it. Great. So it is ready. Let me call it. I am calling it and I am printing it. I think I am done. So let me just execute it. Okay. So I will maybe keep this code here and I will execute it in another window. So let me do g++ sum3 gcc. -w all always use sum3.c. I get a warning unused variable I, line number 32, because the loop I have removed, I have moved to the function, so I is no more used. If I don't use -w all, then I don't get that warning. This is the benefit of -w all. We should write perfect code, no warnings, right? So I will, with gratitude, fix this error. Okay, a clean, well indented, elegant and correct code is what we aim for. I run it and you have got the sum. It is good. So the first part is done, taking it into taking it in the computing it in the function. That first part is done.